Today, lesson 5B, the second day of the elimination method. Today we finish up this idea of the elimination method. Yesterday, our focus was on systems where we didn't really have to do much. We could add straight down and one of the variables were eliminated. Or, towards the end, we had to multiply one equation by something. And remember, when we do that, that really is the multiplication property of equality. Well, today we get to systems that are a little more complicated, but the same thing applies as far as how we attack a system of equations using the elimination method. So, background knowledge. We talked yesterday about the fact that we've talked about the graphing method of solving a system, where we're looking for where they intersect each other. That's not always the best method. We then talked about the substitution method, and today we finish up this idea of the elimination method. And here were a few problems that we talked about yesterday, where we're trying to eliminate a variable by adding straight down. I also told you that sometimes the elimination method is referred to as the addition method, and that's exactly the reason why, because we add straight down. So that was one problem we did yesterday. We also talked about sometimes that they're both not in standard form, so sometimes we may have to turn one of them into standard form. And then we talked about the idea that sometimes we have to multiply one equation by something to get something to be eliminated. Like in this one, we decided to multiply the bottom equation by -2, and so on. So let's go to, as I finish this one up, today's. Here's number one for today. Notice, first of all, that nothing is eliminated if you add straight down. Also notice that if you want to multiply by integers, it is impossible to get something to cancel out by only multiplying one equation by something. But the rules are, you can multiply either equation by anything that you want, because once again, when you're doing that, that's the multiplication property of equality. But once again, you can multiply either equation by anything that you want, as long as you can somehow find a way to eliminate a variable. Can somebody think of one thing that we could do? And there will be many things that you could do. You just need to find what you think might be the easiest thing to do. Yeah?
Times the first equation.
Did you say times?
Multiply the first equation by 2 and multiply the second equation by 3.
Okay, so if you are going to multiply the top equation by 2 and the second one by 3, what variable is eliminated?
It would be 6.
No, just tell me which variable is eliminated.
Y.
Okay, why? What if instead you wanted to get the x's to be eliminated first? What could you do then?
Multiply the top equation by -2 or positive 2.5.
Whoa. Okay. So one of the things I first said was, if you wanted to only multiply by integers, it's impossible to do by only multiplying by one thing. You were trying to get around it by multiplying the top one by 2.5. Yes, that will work. But if you do that, now you're creating a mess, in my opinion, because now that entire top equation is all decimals, right?
Yeah.
But it would work. Getting back to my question, what could you do if you wanted the x's to be eliminated?
Multiply the top equation by 5.
Yep.
And multiply the bottom equation by 2.
Okay. It doesn't matter which direction you go. Pick which direction you want to go and try it out. As I'm walking around, I like the fact that many of you are taking the solution that you came up with and you are quickly plugging that solution in to make sure that it is a solution. That's what you should do. All right, let's take a look at number one. I am going to multiply the top equation by 5, bottom by 2. And that way, my x's are eliminated by adding straight down. When I do that, I end up with 11y equals 33, and we can easily see that y is 3. From there, I need to substitute that back into either of the two original equations. It doesn't matter. I'm going to use the second one because I want to, and that would give me this. Simplify and solve, and I get x equals 2. So the solution is 2, 3. And once again, I've said this almost every single problem, you should quickly check by plugging 2 in for x there, 3 in for y there, 2 in for x there, 3 in for y there, and make sure that it makes a true statement, and of course, it does. All right. Everybody try number 2. Much work, but let's take a look at this. I am rewriting it, and then I am going to multiply the top equation by -5 and the bottom one by +3. And when I do that, you can see that my x's are canceling out. And you're going to have to do a little bit of thinking and make a decision on what you want to get to cancel out. And when I say cancel out, for the 2 of you who weren't here yesterday, we need things to be opposites right there. And then the other comment I have is that 2 of you were not, you're trying to do too much in your head from this point on right here. You really should rewrite them so that it becomes very clear exactly what is happening here. So my x's are eliminated by adding straight down. I have 11y equals -44 because -20 and -24 make -44. Divide by 11. We get y equals -4. From there, you can plug it into either equation. To me, it looks like the first one is easier to deal with. So that's where I'm going to substitute it into. That gives me this. And when I solve, I get x equals 2. So my solution is 2, -4. And I should mentally check to make sure that that works. All right. Let's give number 3 a shot. I took the system and multiplied the top one by 2 and the bottom one by 5. And once again, I told you that I try and look for the easiest thing to do. And for me, that's the easiest thing to do. And the y's are eliminated by adding straight down. We can see we get x equals 1. Substitute that into either equation. I'm going to use the first one. Some of you might think the second one's easier. It does not matter. And we get y equals 5. So the solution is 1, 5, and we should be checking to make sure that that works. All right, a couple problems left. Let's try number 4. Make sure you're doing number 4 and not number 5. All right, so what's different about this one compared to everything else that we've done so far? Yes?
Both equations cancel out.
Okay, so what do you end up with? I mean, this is not the first time where we've dealt with a situation where things have canceled out, right? So when variables cancel out, in every other type of problem that we've talked about this year, and I think this is the 4th or 5th time we've come into a situation like this, right? When the variables cancel out, something happens.
It's infinite solution.
Why?
Because you end up with 0 equals 0, and that's a true statement.
Exactly. When the variables start canceling out, which this is what happens in this problem, we either end up with a true statement or a false statement. 0 equals 0, which when everything cancels out, that's what we end up with. 0 equals 0. That's a true statement. Therefore, like every other time we've ended up with something like that this year, we end up with either all real numbers or an infinite number of solutions. And so we have to keep that in mind. Everybody now try number 5. Please notice in number 5 that the second equation is not in standard form. So you should put it in standard form first. All right, let's take a look at number 5. As most of you have seen, similar situation here. In the second equation, we do need to put it in standard form. And then when we multiply the top one by -2, we end up with variables canceling out again. However, this time we end up with 0 equals 2. That is a false statement, therefore no solution. So much like situations before, when both variables are eliminated, something different is going to happen. If we end up with a false statement, we end up with a no solution situation, and a true statement, we end up with an infinite number of solutions. All right, we are finished.